multi-level dimensional analysis problems. In this problem, we're going to be able to convert 40 kilometers per hour into miles per hour. In order to change from kilometers to miles, we're going to need an equality. So the equality provided for this problem is that there's 1.609 kilometers for every mile. This equality can be written as a fraction. So if we use this as a fraction, we're going to be able to convert the kilometers into miles. So let's take our 40 kilometers per hour and multiply it by the equality that every mile is the same as 1.609 kilometers. Notice I put the kilometers on the bottom part of the fraction for the equality that we're multiplying through by, because I want that unit to cancel, as you see highlighted in yellow. The kilometers cancel, and the unit that we're left with is miles per hour, what we have highlighted over to the left. 40 has two significant figures. 0 at the end gets to count because there is a decimal place in that number. So our final answer will be rounding to two significant figures as well. So our final answer ends up as 25 miles per hour. Problem number 2, we're going to convert 10 gallons into liters. In order to make this conversion, we're going to need several equalities. We're going to use the fact that 1 quart is equal to 0.946 liters, and that every gallon is 4 quarts. This will be a two-step dimensional analysis problem. We'll be changing the gallons to quarts and then the quarts onto liters. So to get started, we're going to multiply the 10 gallons by the equality that there's 4 quarts per gallon. And in this case, you're going to notice that the gallons are going to cancel out, as highlighted in yellow. If you have a unit on the top and the bottom part of a fraction, they cancel. At this point, if we were to multiply everything out, the 10 times the 4 divided by the 1, you'd actually have an answer that would be in quarts. In that case, it would be 40 quarts. The answer that we need, though, needs to be in liters, as highlighted in the top left box. So if we continue on using our second equality, we're going to be able to change quarts onto liters. And we can now see that every quart is the equivalent of 0.946 liters. Notice that the quarts are going to cancel, as highlighted in yellow. If you have a unit on the top and the bottom part of a fraction, then they're going to cancel. Notice the only unit that is left now is liters, highlighted in white. And if we multiply everything out, the 10 times 4 divided by 1 times the 0.946 divided by 1. And we round our final answer to 3 significant figures because the 10 that we started with has 3 significant figures. Both zeros and 10.0 get to count because there's a decimal place in that number. So our final answer here, rounded to 3 significant figures in liters, will be 37.8 liters. The next unit that we'd like to change is 2 yards cubed into meters cubed. This is a volume conversion. To help us with this volume conversion, anytime you have a length cubed, you are dealing with volume. We are going to use a length equality to get us started. Notice I provided that a meter is the equivalent of 1.094 yards. That is a length equality. But if you recall, what we are solving is a volume problem. We're trying to convert yards cubed into meters cubed. So if you would like a volume equality, all you have to do is take the length equality and cube both sides. If you cube 1 meter cubed, 1 cubed is just 1. But on the other side of the equality, 1.094 cubed becomes a 1.309 yards cubed. So to take a length equality and change it into a volume equality, all you need to do is cube both sides of the length equality. Both the number and the unit must be cubed to make this conversion from a length equality to a volume equality. Now, using our volume equality, we can go ahead and change the 2 yards cubed into meters cubed. Notice when I multiplied through by the equality, I made sure to put the yards cubed on bottom because that's a unit that I would like to cancel. Notice that unit does cancel, so we'll highlight it in yellow, leaving the meter cubed as the final unit. If we now did the math, 2 times 1 divided by the 1.309, we'll obtain our answer. And if we round our final answer to 2 significant figures, because 2 has 2 significant figures, a 0 at the end gets to count because there is a decimal place. Our final answer here will be 1.5 meters cubed. Now, if you did not use a volume equality here for this conversion, then you would not have ended up with this final answer of 1.5. So once again, to change a length equality to a volume equality, all we had to do was cube both sides. In this conversion, we're going to be changing 5 inches squared into centimeters squared. This is an area equality. Just as we did with the volume equality where we had to take a length equality and cube both sides, here to get an area equality, we're going to take a length equality and we're going to square both sides. So if we use the length equality, that 1 inch is the same as 2.54 centimeters, then we can take that length equality and square both sides. 1 squared is obviously just 1. If you go over to the other side of the equality, the fact that 1 inch equals 2.54 centimeters, the 2.54 squared gives us the 6.45. So now we have an area equality for solving this area conversion. So now we will be able to change the 5 inches squared into centimeters squared. So if we multiply the 5 inches squared by the area equality, making sure that we put inches on the bottom part of that fraction because we're wanting that unit to cancel, the inches squared. Notice I'm going to highlight that in yellow so that you can see how that's going to cancel, leaving us with the desired unit in this case of area in centimeters squared. To report our final answer, we're going to want to round it to 3 significant figures. 5 has 3 significant figures. The zeros at the end of the number get to count because there is a decimal there. So the appropriate answer here to 3 significant figures will be 32.3 centimeters squared. The units of inches squared have obviously canceled. The next type video that we'll be looking at will be multi-step dimensional analysis problems, where you have to go through several conversions in order to get to the final end result, the final unit that you're looking for. This will be in video 3.